one 5-mark question. So that is to solve the linear programming problem using graphical method, or they may ask you one 4-mark question under part E section, that is to formulate linear programming problem. So the formulate to LPP is to maximize the profit, so or minimize the cost. By graphical method means x and y greater than 0 means it lies in the first quadrant. Hence our solution will lies in first quadrant. Hello everyone, a warm welcome to one and all. This is Yashati ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. We are at this revision sessions of the chapter-wise question and answer, and here in this session I am taking the revision concepts on linear programming problem. So in this chapter you may get 4-mark question or one 5-mark question. So either they will ask you to attempt one 5-mark question, so that is to solve the linear programming problem using graphical method, or they may ask you one 4-mark question under part E section, that is to formulate linear programming problem. So they may give you one 4-mark or one 5-mark question from this chapter. So first let us see how to formulate a linear programming problem for 4 marks. Then we will study or find the solution of linear programming problem using graphical method. So here is a 4-mark question. A company produces 2 products P and Q. Each P requires 4 hours of grinding and 2 hours of polishing, and each Q requires 2 hours of grinding, 5 hours of polishing. The total available hours for grinding are 20, for polishing is 24. Profit per unit of P is 6 and that of Q is 8. Formulate the LPP. Here a company is manufacturing 2 types of product, one is P and Q. P is taking 4 hours for grinding and 2 hours for polishing, and Q requires 5 hours of polishing and 2 hours for grinding. But the total time available for grinding is 20 hours and for polishing is 24 hours, and profit per 1 unit of P is rupees 6 and profit per 1 unit of Q is rupees 8. We have to formulate the LPP. So the formulate to LPP is to maximize the profit, or minimize the cost. So this is the basic thing, that in linear programming problems either we will maximize the profit or we will minimize the cost. So here the cost per unit is given. So therefore my objective function will be to maximize the profit. So that is Z is equal to, so cost per unit of P is rupees 6. So that is why the total cost I will take it as 6x. Total number of units be X for P and total number of units be Y for Q. So therefore total cost will be 6x and for Y it is 8y. Subject to 2 constraints. We have a constraints for grinding, polishing, because the maximum hour requirement for grinding is 20 and for polishing is 24. So therefore subject to constraints. So let's see how many hours required for unit X and Y. So product P I have taken it as X, product Q I have taken it as X. Let's write the equation for grinding. So that is, grinding is P requires 4 hours of grinding, so therefore it is 4x, plus, and Q requires 2 hours of grinding, so therefore it is 2y. And maximum hours you will get for grinding is 20. So therefore it must be less than or equal to 20. So this is the equation for grinding. Next, let us write linear inequation for the polishing. We need 2 hours for X and 5 hours for Y. That is product Q, and maximum availability of hours for polishing is 24. So therefore it is less than or equal to 24. The maximum it can take is 24. Hence the consume of hours must be less than or equal to 24. Now the solution whatever we will get will be positive, that is in the first quadrant. So therefore here both X is positive and Y is positive. So therefore to frame this equation you will get 4 marks. So write the conditions whatever they have given. So this is my objective function subject to constraint. What are the constraints we have? Constraint for grinding, constraint for polishing, and write it since both X and Y are positive. just represent it as x is greater than 0 and y is greater than 0. Second question. Prateek wants to decide the constituents of diet which will fulfill his daily requirements of proteins, fats and carbohydrates at minimum cost. The combination is made among two food products A and B whose contents are indicated below. So this is the minimum requirements of proteins, fats, carbohydrates of food A and food B. And this is the cost per unit for food A and food B. So the proteins in terms of milligrams for food A is 5, for food B is 2, but minimum requirements that you have 18 milligrams of protein. Fats, or Prateek has fats 6 and 5 for food A, B, and minimum requirement is 200 milligrams. So carbohydrates is 5, 3 and it is 700 milligrams. Cost per unit of food A is 70 rupees. Cost per unit of food B is 30 rupees. Here we have to minimize the cost. Hence, our formulation of LPP will be the minimum or minimize. So previously we have to write here maximize because we are gaining the profit. So write the word maximize because it is for profit, and here it is about the cost. Whenever a question arises for the cost, it means you have to minimize the cost. So therefore write minimize. So what is the cost per unit A? 70 and cost per unit B is 30. So let me take it as Z is equal to 70x plus 30y. Now what are the requirements we have, or what are the constraints we have? Subject to constraints. So we have a constraints for protein, fat and carbohydrates. So for protein it is 5, 2 and overall requirement is 800. So therefore it is 5x plus 2y. Here we have to write greater than or equal to 800 because this is the minimum requirement. So maximum it can take any number of values. Next, fats it is 6 and 5. So therefore it is 6x plus 5y greater than or equal to 200. Next is carbohydrate. It is 4x plus 3y greater than or equal to 700. So write x comma y greater than or equal to 0. So this is how we have to formulate the given statement. So next question. So these are all 5 marks question. So the graphical method of finding solution to LPP. Maximize z is equal to 5x plus 3y subject to 3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10. So here we have two linear inequalities and given that x and y is greater than 0. By graphical method means x and y greater than 0 means it lies in the first quadrant. Hence our solution will lies in first quadrant. And we have to solve these inequalities, that is by drawing a line. So let's take first equation 3x plus 5y less than or equal to 15. So let's write the points for this. We have x, y. If x is 0, y is 3. If y is 0, x is 5. So therefore the points are 0, 3 and 5, 0. So this is the points for the first equation. Let us find points for the second equation. 5x plus 2y less than or equal to 10. Hence, just write the solutions. X, y. If x is 0, y is 5. If y is 0, 2. So therefore the points are 0, 5 and 2, 0. Now let us plot this in coordinate axis. So let us take x axis and y axis here. So look at the maximum value you have, that is 5. So hence let's take it as 0, 1, 2, 3, 4, 5, 6. Here it is again 1, 2, 3, 4, 5. So now let's plot the points for the first straight line. So that is 0, 3, 5, 0. So 0, 3, 5, 0. So this is the straight line. Next we have 0, 5, 2, 0. So 0, 5, 2, 0. So this is what the equation or the straight lines we get. So write the equation of the line. So for the first one it is 3x plus 5y. So this is the equation, 3x plus 5y is equal to 15. And second equation is 5x plus 2y is equal to 10. So this is 5x plus 2y is equal to 10. So next here, since both conditions are less than or equal to, that means the region lies below the line. Which is the region which is common to both, satisfying both the condition? That is this. So mark the region as this is O, A, B, C. Now, after marking the region as OABC, so this is the feasible region or the solution region. So here I can write it as OABC is the solution region. Solution region. So sometimes we can also write it as feasible, which is nothing but solution or solution. So now write the points of this. So these are the corner points. These are called as corner points. So mark these corner points here. So for O, just put corner points. Write the coordinates of the points. O it is 0, 0. A is 2, 0. Let's calculate B. And C is, here it is 0, 3. Just write it. Now by looking at the diagram here, calculate the x coordinate and then y coordinate. Here you will get the straight line. Since here I have taken a rough diagram, I'll directly write, but by looking at your graph, just look number of counts for x-axis and number of counts for y-axis. So here I'll just write this in terms of fraction. I will get it as 20 by 19, 45 by 19. So this is the coordinate of B I will get. Now which is my objective function here? So my objective function is z is equal to 5x plus 3y. So z is equal to 5x plus 3y. Substitute the value of x and y and calculate it. So for the first one, I'll get it as 0. For the second one, it is 10. So when you calculate it, you will get it as 235 by 19. So approximately you will get it as 12.37. Next one is 0, 3. I'll get the value of 9. So which is the maximum value? So this is the maximum value. So hence we have found the maximum value. So therefore we will write Z max is equal to 12.37. So hence we have found the maximum value. So this is a 5 marks question. So here they have given a standard linear equations here. We have to find the solutions of the linear equation graphically, then find the feasible region, finding the corner point, substitute in the table and verify for Z, find the maximum value. Next question. Minimize z is equal to 3x plus 5y subject to x plus 3y greater than or equal to 3, x plus y greater than or equal to 2, x comma y greater than or equal to 0, which implies solution is on first quadrant. Now here let us take the points for these two inequalities. So if I put x is equal to 0, then here y is equal to 1. If I put y is equal to 0, then x is equal to 3. So therefore the points are 0, 1 and 3, 0. Next let me take one more, that is x plus y greater than or equal to 2. So here x and y, if x is 0, y is 2. If y is 0, x is 2. So therefore the points are 0, 2 and 2, 0. Now let us plot this. So take y-axis, x-axis. So 0, 1, 2, 3, 4. 1, 2, 3, 4. So this is y-axis, this is x-axis. Now what are the first point? 0, 1, 3, 0. 0, 1, 3, 0. Draw a straight line. What is the equation of this line? X plus 3y greater than or equal to 3. Here x plus 3y is equal to 3 you have to write. Next, 0, 2, 2, 0. 0, 2, 2, 0. What is the equation of this line? X plus y is equal to t, 2. So here both the conditions are greater than. That means the feasible region lies above the lines. So which is the region which is satisfying both the conditions here? It has to pass above the line here. This is the region you can see. Which satisfy the region. So here mark the end point. So this is one of the end point. Here is one more end point and this is the other point. Mark this as A, B, C. And this is this feasible region. Write it here. You can write it as feasible region. Now write the corner points. So corner points. So we have A, B, C. So the corner point of A is 0, 2 and C is 3, 0. So let's find for B. So approximately you will get it as 1.5, 0.5. So this is what you will get, 1.5, 0.5. Now let's look at the optimal function here, that is z is equal to 3x plus 5y. Z is equal to 3x plus 5y. Find the values. 0, 2 means it is 10 here. So 1.5 into 3 plus 0.5 into 5. So that is you will get it as 4.5 plus 2.5, 7. Next is you have 3 3s are 9. So which is the minimum value? This one is the minimum value. What is my aim? To minimize the given optimal function. Hence we have found the minimum value. So we write Z minimum is equal to 7 at the point 1.5, 0.5. So this is the solution for the given linear programming problem. Next one. Maximize z is equal to 60x plus 5y subject to x plus y less than or equal to 50, 3x plus 5 less than or equal to 90. So again here this is the question. We have two straight line, x plus y less than or equal to 50. Find the solution by taking different points x and y. X is 0 means y is 50. Y 0 means x is 50. So therefore the points are 0, 50 and 50, 0. Next take the next equation. We have 3x plus y less than or equal to 90. Take the solution here. So we have x and y. If x is 0, y is 90. If y is 0, x is 30. So the points are 0, 90 and 30, 0. Let us plot this in a graph. So I'll take a coordinates here. X and y axis, x, y, origin. I'll take the coordinates in the form of 20, 40 like that. So here it is 20, 40, 60, 80, 100. Here also 20, 40, 60, 80, 100. So now let's plot it. The first point is 0, 50, 50, 0. 0, 50, 50, 0. So this is the straight line. What is the equation of this line? X plus y is equal to 50. Next one is 0, 90, 30, 0. So 0, 90 and 30, 0. So this is the straight line. What is the equation of this line? 3x plus y is equal to 90. Now for both the case we have less than or equal to, less than or equal to. That means the region lies below the line. Which is the region satisfying both the condition? This quadrilateral. So mark the corner points here. So this is obviously O. Let me take it as A, B, C. Write it in a table, that is corner points. Corner points is equal to O, A, B, C. So origin is nothing but 0, 0. A is actually 30, 0. Let's find B. Write C. C is 0, 50. B is almost, it is 30 and here it is 20. That is 20 comma 30. So 20 comma 30. Now my objective function is z is equal to 60x plus 15y. 60x plus 15y. So if both are 0, it is 0. Now x is 30. So 3 6 are 1800 I'll get. Here 6 2s are 12. 15 3s are 45. So 1650 I will get. So next here I have 16 to 0 0. 15 into 5 75. So total 750. Which is the maximum value? 1800 is the maximum value. So therefore Z max is equal to 1800 at the point 30, 0. So this is the solution for the given linear programming problem. So hence these type of question they may ask you for your examination. One, either they will ask you to formulate LPP or they will ask you to solve LPP graphically. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.